Please welcome Arjun Bhuptani. He's now the CEO and founder of Connext. Arjun is the mastermind behind Connext, a groundbreaking protocol that powers secure, generalized communication between blockchains. And now he will share with us his thoughts on how to build an interoperable applications that help leverage the infrastructure and ecosystem of multiple chains. Let's welcome him with a speech, Building xChain App.
Hi, I'm Arjun, that's me. I'm one of the founders of Connext. Connext is a protocol that allows you to communicate between blockchains. So in today's very, very interesting multi-chain world, Connext is a project that allows you to kind of solve the fragmented experience of having to interact with applications that live on multiple chains at the same time. So here's an example. This is Aave. How many of you use Aave? Awesome. Aave is a lending protocol that is built on top of Ethereum and then also all of these other chains. When you use Aave today, there's this really confusing experience where you have to go and select a chain specifically that you want to lend on or borrow from. And in order to actually find the best rates on every chain or on all of the chains altogether, you actually have to go through each and every single chain independently. Not only that, but if you're kind of interacting with Aave and you decide, hey, I've lent funds on one chain, and then you decide you actually want to unwind your position and move to a different chain, you have an even more confusing experience where you have to pull funds out of Aave, leave the Aave application, go to a bridge, bridge your funds to another chain, and then put those funds back into Aave. For most people, especially people that are new to the space, this whole experience is nonsense. It doesn't really make a lot of sense to send your users to another application, and it also doesn't really make sense for users to have to learn what a chain is in the first place, right? Users want to use apps. They don't necessarily want to learn how the technology behind a given decentralized application actually works. So how should this work? The right experience for Aave is to have a single unified interface, like one place where you just borrow and lend. And in the background, Aave should actually take care of the process of sending your funds to one chain or another. Right? And that intuitively makes sense. You don't, when you're using Google today, for example, you don't, and you look up, cat videos, you don't have to consciously think about where those cat videos are stored. You don't have to think about, okay, the references to these cat videos are distributed across a bunch of sharded databases in Google servers. You think, okay, I'm just going to see an application interface that has videos on it. The experience that we are building in this space really matters because ultimately, in order to be able to scale, in order to be able to bring on people from outside of the space, we need to make sure that we mirror what actually happens in Web 2 as well. So I've been talking a lot about cross-chain. And I think that makes people a little bit nervous because cross-chain is a bad word. And there's a good reason for why cross-chain is a bad word. In the past year, we've lost about $2 billion to hacks in bridges. It's a very, very large amount of money. It's no secret that the bridge ecosystem and bridge's reputation is actually in a very, very bad place. And there's a really, really good reason for it. So how do you actually, do we even need bridges in the first place? Why do they actually exist? Now, the unfortunate thing is that one thing we've realized over the course of trying to build applications in this space over a very long period of time is that in order to scale, you actually have to move to multiple different blockchain-like environments. You can't build every single application on a single blockchain. It doesn't make sense. Ultimately, you hit the same scalability limitations no matter what blockchain you're using, because ultimately, there's physical limitations to basically how large you can scale a single distributed system. So do we really need bridges? Well, regardless of whether you believe in a multi-chain world or if you believe that we're heading towards a world where there's multiple rollups building on top of Ethereum, or you're in Cosmos and you have the interchain ecosystem, or you're Polkadot and you have another interchain ecosystem, ultimately, you actually need to be able to communicate between these blockchains. And so it's all bridges, right? Rollups posting data to Ethereum is a bridge. Data availability layers, posting data to settlement layers is a bridge. Rollups being able to communicate between each other, also a bridge. Eventually, this whole ecosystem just becomes bridges and layers. So if we're forced into a world where we have to have bridges, how do we build them safely? This is actually the really big challenge that a lot of the bridge projects, including Connext, are facing currently. How do you actually build infrastructure that's so critical in a way that it doesn't break and it doesn't get hacked? And when it does get hacked, how do you avoid the risks of things like contagion? So contagion is this thing where if you have, for example, Polygon, right? The Polygon POS bridge is how you bring assets from Ethereum over to the Polygon ecosystem. How do you stop the risk if the Polygon bridge gets hacked? How do you stop the risk that the entire Polygon ecosystem just disappears overnight? And that is, you know, again, billions and billions of dollars in value that can just vanish. So some of the things that we've been looking at are modularizing bridges. What that means is basically breaking out each of the different components of bridges in a way where you can separate out the risks of them independently. So for example, have transport, which is how do you get data from here to here, basically simple hashes from here to here, be separated from verification, which is how do you enforce the security of those hashes? How do you enforce the correctness of them? And have all of that be separated from liquidity. So how do you actually bring liquidity and value between chains? The second piece that I think is quite important is minimizing external dependencies. So if you look at a lot of the bridge hacks, for example, the wormhole bridge hack, right? The wormhole bridge hack was caused by a cryptography dependency on Solana that was actually implemented slightly differently than on Ethereum. And that cryptography dependency had a vulnerability in it. This is kind of the risk that you take when you're building on top of blockchains, especially a lot of different kinds of blockchains, is that you inherit any security issues that they all contain. And in Wormhole's case, one small issue in Solana caused a $350 million hack. Next, one of the key things that we're seeing is using delays. So do you need to be able to send hundreds of millions of dollars across chains immediately? Probably not. Right? I think it's, in most cases, if you're a fund or a liquidity provider or a market maker that is transferring $100 million across chains, you're probably okay with waiting 15 to 30 minutes. And that delay is long enough to be able to have off-chain actors, basically what we call watchers, watch the chains and make sure that that transaction is bona fide. Make sure that that transaction isn't happening as the result of a hack. And that actually brings me to the last one as well. More generally, just rate limits. You know, how do we stop the risk of hacks in this space is just to implement rate limits that stop an attacker from stealing all of the funds in a single transaction, right? So if you limit the ability to withdraw funds so you can only withdraw, say 10% of the funds in 5 minutes, you can shut down a system before all of the funds are lost. And I think that this is true not just for bridges, but also for the DeFi ecosystem overall. And a lot of the core research that is going into security here is going to be applicable to the rest of the DeFi ecosystem. So what is Connext and how does it work? Connext is a mechanism to communicate across blockchains. The way that we minimize risk is that we try to use existing bridges as much as possible. We try to use AMBs, which are arbitrary messaging bridges, that exist within a given ecosystem. So for example, the Polygon POS bridge is an AMB. The Gnosis chain bridge is an AMB. But this also includes things like the rollup bridges, so the bridge to get into and out of Optimism and Arbitrum. By using those existing pieces of infrastructure, we're limiting the additional risk that a user has to take on as part of interacting across chains. So, if you're a user that is holding assets on Polygon, you're already taking on the Polygon POS bridge risk. So we can basically avoid having users take on additional risks that they would not have had to take on otherwise. And of course, in most of these cases, you have delays baked into the AMB. So in Polygon, this is 3 hours to exit, or I think it's 2 hours now to exit, 15 to 30 minutes to enter. In a rollup, that is 7 days to exit, and then a few minutes to enter. So we have basically what we call an execution layer that sits on top of this lower level ecosystem of bridges. And that execution layer allows you to make transactions happen quickly. Because as a user, you don't want to wait for 7 days for your transactions to go across chains in the first place. And so our execution layer just makes the transaction happen immediately. This happens through a network of off-chain actors called routers. And those routers are then repaid over the slower AMBs. That was a lot. That was very, very technical. Jumping back to kind of the higher level piece here, what does Connext actually let you do? It lets you build cross-chain applications safely. We think that if we figure out this bridge problem, if we figure out how to make secure bridges in the first place, the future looks like a world where every single application will be cross-chain. And this is similar to how you build applications in places like JavaScript. So we introduce within Connext this primitive called xCall. xCall is a simple mechanism that actually maps to the lower level Solidity call function. So Solidity has a call function that allows you to call a contract on the same chain, basically just execute a transaction against some contract function on the same chain. xCall is the same thing but across chains. So rather than doing a synchronous call to a function on the same chain, you can do an asynchronous call to a function on a different chain. This is really, really similar to how JavaScript works. And in fact, a lot of these core ideas are the same, right? Why does JavaScript and why does web development look the way that it does? Why do you make asynchronous calls across, like, to get something in JavaScript? Well, it's because the server that you're fetching data from exists on the other side of the planet. And so you don't know on the internet, you don't know if that the request that you're sending is going to get a response. You don't know how long it's going to take to get a response. And so you kind of have to shoot it off into the dark and see what happens. And while you're seeing what happens, you can go and do things, right? You can continue the execution of your program, and you can just wait for that data to come back. xCall works in the same way. With asynchronous Solidity, you can make a transaction to a contract on a different chain in the same way that you make a transaction to a contract on the same chain. But because it's on a different chain, you don't know that that transaction is going to happen immediately. I mean, it's not going to happen immediately, right? It's not happening within the same block like it would in a normal transaction. And so now you have this asynchronous paradigm. You xCall across chains, and just like JavaScript, you can optionally also specify a callback, which returns data from like a function on a different chain that you can then use to execute something again on your source contract. There's supposed to be an emoji here, but it's gone. So one of the things that makes this particularly interesting is that we've tried to make this behave as closely to existing Solidity development patterns as much as possible. So for example, gas fees. How do you actually pay gas across chains? That's actually a really, really difficult technical problem, right? Because when you pay fees for a transaction on a single blockchain, you are executing whatever's happening in that transaction, and you know after the execution is complete exactly how much should be charged. And so fees are taken from your account right away as part of the same transaction. But across chains, it's a little bit of a different experience. When you execute a transaction across chains, you don't know how much it's going to cost you because you don't know when it's going to get executed. You don't know who is going to execute it. And you don't know what the gas on one chain, so if you're on Ethereum, you don't really know on Ethereum how much the price of gas is on Polygon at any time. What we've done is basically try to keep this as simple as possible. When you make a cross-chain transaction, you pay gas on your source chain in the same, using native assets in the same way like that you would with any other transaction. And if it's not enough gas, you can bump gas. Again, exactly the same experience that you would have with building an application in Solidity today. And then, if you bump gas, that basically means increase the amount of fees at a given transaction. If you didn't have enough fees to begin with, bumping gas basically can help it push it through faster. In practice, this is what it looks like. It's simple, right? I mean, it's designed to be simple. And despite being so simple, we think it's incredibly powerful. Because it's such a generalized primitive, because it's such a generalized way to actually build things, you can build pretty much anything on top of it. So these are some of the examples of projects that we've been working with, and I'll kind of like step you through the constructions of them, so you can see like the kind of domain and scope of the types of things that can be built in this cross-chain world. Superfluid is basically a money streaming protocol. So Superfluid lets you, if you, for example, you want to pay somebody, instead of paying them either upfront or paying them on a monthly recurring basis, you can put money into Superfluid and it just pays out money on a per block basis. So it's basically called real-time finance. So for example, if I decide to pay somebody $100, I can, over the course of a week, I'm basically paying them a certain rate per minute. And that person can receive, X amount of dollars per minute, and then withdraw everything that they have received so far. It's a really low-risk way to do payments, especially in decentralized communities. We use Superfluid, actually. Connext uses Superfluid to pay about 80 people in our community. And they're paid on a daily basis. One of the big challenges of Superfluid right now is if you're an ecosystem that is across chain, so for example with Connext, we have users that are building on top of Polygon, on top of Gnosis Chain, and a bunch of other ecosystems as well. Those users need to be able to be paid out on whatever chain they're on. But for us having to go and set up Superfluid streams on a bunch of different chains altogether is an extremely big operational, there's just a lot of operational overhead there. So one of the really interesting primitives that Superfluid is building on top of Connext is cross-chain money streaming. Being able to set a stream on a certain chain and then have it be paid out on any other chain. And in fact, you can use this not just for payments, but also things like airdrops, right? You can use it for liquidity mining. You can use it for other mechanisms where users are having to be paid on a recurring basis, potentially across multiple chains at the same time. Keeper is another really interesting project. So I think Keeper is quite well known because it was created by Andre Cronje. Keeper is a network for automation of Solidity smart contracts. So basically there's a network of actors called Keeper bots that submit transactions to blockchains on a recurring basis. It's a decentralized network and they're held accountable by a staking and slashing mechanism. One of the things that Keeper wants to move towards is also becoming a multi-chain network. So being able to enforce, being able to do the same kind of activities that they do where they, for example, on Yearn will call the harvest function which allows to, or actually I don't really know what it's called, but will call a harvest function that allows them to update yields on their specific contract. So in order to be able to do this across chains, Keeper needs to build this broader multi-chain Keeper network. And one of the key primitives there is bringing TWAPs across chains. So Uniswap TWAPs are basically oracles of price that exist based off of the Uniswap trading data. One of the biggest difficulties that projects face, including Keeper, is being able to access that oracle data on any chain at the same time. FujiDAO is another really interesting one. So FujiDAO is actually solving the problem that I talked about at the start of this talk, which is lending aggregation. How do you have a single interface for something like Aave? FujiDAO also does it on top of Compound, Trader Joe, a bunch of other protocols. But the core idea is very, very simple, right? It's lend on any one chain and borrow on any other chain. Intrinsically, that feels like the right experience to give to users. NFT Hashi, another really, really interesting project. It's an NFT bridging and cross-chain NFT protocol. So right now, if you're building an NFT project, your NFTs are locked into a single ecosystem. So NFTs building on Polygon cannot actually trade on, Arbitrum's, what's it called? The marketplace that's on Arbitrum. Or NFTs building on top of Optimism can't trade on OpenSea. That's a really fragmented and siloed experience, and it's also really bad for the marketplaces that want to be able to get the largest user bases they can. NFT Hashi solves that. It allows you to have NFTs that actually exist on multiple chains at the same time or can be brought to any other chain. And lastly, Gnosis Zodiac. So Gnosis is building this, within the Gnosis ecosystem, there's a project called Zodiac which is basically building DAO tooling. One of the key things that they want to enable is cross-chain governance. So being able to have a proposal that exists on one chain be executed from any other chain. And a good example of this is, for instance, Uniswap needs to update their fee tiers on Polygon, but Uniswap's DAO exists on Optimism. How do they do that? The goal is to move towards not just being able to do things like that, but also have cross-chain voting. So allow users to have Uni tokens on any chain and vote with them from anywhere. Again, intuitively this makes sense, right? Needing to be able to bridge your Uni tokens to vote is something that people just won't do. It costs money and it takes time, and it's already hard enough to get people to vote as it is. These are some of the key examples of people that are building on top of us already. But there's other things too that I think become really possible once you have like generalized cross-chain communication that can be built securely into any chain. One of the ideas that I'm very, very interested in is how can we expand the scope of building on top of blockchains beyond just having smart contracts running on top of something like a rollup, right? A smart contract running on Optimism has a very, very limited scope of functionality. And that scope of functionality is basically just like executing relatively simple code. But what if you could actually connect contracts running on top of Optimism to Filecoin or Arweave, right? What if you could actually bake storage directly into the execution layers of all of these different chains? Well, that would allow you to build full stack applications on blockchains. That's like a revolutionary idea. Imagine building Google on a blockchain. You could do that. And in that world, basically what's happening is Optimism or whatever your execution environment is doing the compute. It kind of is like an Amazon EC2 instance. It's communicating with Filecoin or Arweave for storage. It might be working with other kinds of compute networks, perhaps GPU networks like Golem. Basically any kind of decentralized resource network that has a VM can be plugged into this broader network. Anyway, this is a little bit of a taste of what cross-chain means, how Connext is thinking about it, and how the world that we believe can exist once this problem is solved. I think that it's still very, very early. A lot of people are still just now starting to grasp some of these ideas. I know for a fact that for most people, like even the concept of I could have an application that lives on top of multiple chains simultaneously is a very, very novel idea. And so we're really only just getting started with exploring this space. Thank you so much for listening to the talk. If you have any questions about this, definitely come and talk to me afterwards, because I'd love to talk about cross-chain stuff.
Thank you, Arjun, for your sharing.